So this is A2Pure Maths. We are in Unit 5 and we're taking a look at some examples then of functions. So it says if the domain of a function is not stated, it should be assumed to be the set of real numbers R for which the function then is defined. So the following functions map an element of X of the domain onto its image, and as in F, the function takes you from X to Y. So for each of the following three functions, state the domain for which the function is defined, the corresponding range, and whether the function is 1-to-1 or many-to-1. So let's take a wee look at part A, and it's really asking us for three things, so we'll just set them out like that. So first of all, it is asked for the domain. So it hasn't mentioned here where we are, so we'll assume then it's for the real numbers. So domain is all real X. So domain is written then like this with my R. Part 2. If we put all the numbers, all the real numbers into this, what do we get out? It's pretty much then the same again. So it's going to be range is all the real numbers. And then part 3, for any time you put a number in, you get another number out that's going to be 3 bigger. So it doesn't make any difference. There's no way you can get the same number out by putting in a different number here. So it's all just going to be 1-to-1. So we'll write that as a wee sentence. So each element of range obtained by only one element of domain. So the function then is 1-to-1. Okay, let's take a look then at function B. So B there you can just see, so it's g of x taking you then to the square root of x. So what do we think about this one? What numbers can we put into this if you're going to be taking the square root? Well, you can't take the square root of a negative number, so we need to set this one up differently. So function is not defined for negative x. So our domain, and again just so you can get used to this, you sometimes see things written like this with our curly brackets. X is a member of the real numbers and x must be greater than or equal to 0. For this domain, the range will contain all the positive numbers in R, so it's just going to be the same. If you're only putting the positive numbers here, you're just going to get the positive numbers out. You can't think of it. Whenever you take the square root of a number, there's not a number you can't think of that you can't get in terms of all the positive numbers. So, so for this particular domain, so for this domain, the range will contain all positive numbers in R. Since the symbol means a positive square root, so i.e. the range is y is a member of the real numbers and y is greater than or equal to 0. I hope then that we can see that this one, so each element, it's going to say the same thing as this, each element of the range obtained by only one element of the domain, so the function then in this case will be 1-to-1. Final one then is 1 over x squared, so we can go under next page in for this. And this one then is, so the function then is defined for all real x except for 0, because you can't sub 0, you can't divide by 0, so so my function is defined for all real x except x equal to 0. So domain will be written as x is a member of the real numbers, however x cannot be equal to 0. This one then, so I'll just nearly dictate this. So for this domain, the range will contain neither 0 nor any negative numbers. You can't get the number 0 out of this, obviously, but you also can't get any negatives, because whenever you square your negative number, it becomes positive. So it just gives you that, so it'll always be positive, therefore my range y is a member of the real numbers, and our best way of writing that is y is greater than 0. You've hopefully realized then from the previous one that this one is actually then going to be a many to one function. So elements of range can be obtained from more than one element of domain. And they've given a wee e.g. f of 3 would give us what? Here's our function here, sub 3 in here, I get a 9th. And f of minus 3, sub minus 3 in here, 1 divided by minus 3 squared is 9. It's not negative 9, remember, so that gives me a 9th as well. So that is our case in point, really. So function is going to be then many to 1.